GraphicAlc is a result of intense research and development over 10 years in the areas of parametric sketching and automated graphical calculations and automated geometry back-solving technologies that has created a platform where the users can quickly capture their engineering intents. And then wizards are available on top of the base platform that enable users to add the disciplines of motion simulation, transient data acquisition, and tolerance analysis to the three elements of sketching, calculations, and optimizations within one platform. So with GraphicAlc, you can create a flexible intent model very quickly, which contains both the geometric as well as the mathematical intent of the design challenge. And then you can substitute parameters to ask and receive design decision support information as well as optimal solutions in a fraction of a time what would it take if you were using conventional engineering calculations and drawing tools. To illustrate the principle of operation of GraphicAlc, I have set up a challenge here. You can see there are two circles that are intersecting. The distance between the two centers of the two circles is known, and the radius of one of the circles is known. The challenge is to solve for the radius of the other circle so that this area of this intersection is equal to half the area of the circle on the right. Now, if you were to solve this challenge using handheld calculators or spreadsheets or mathematical solvers mathematical software, this will take quite some time. For example, I did a Google search to find a mathematical solution for this problem, and I found this in a leading mathematical software website. So this is the number of equations that you need to solve just to find the area of the intersection. So instead, let's see now from the starting from scratch how this challenge can be solved in GraphicAlc in using just a few mouse clicks. So I will start a new worksheet. So first I will draw a line using my sketching tools. GraphicAlc's parametric sketching tools are quite similar to the sketching tools found in most popular CAD applications. There's automatic constraining and automatic inferencing of constraint points and conclusion mechanisms so that your original geometry topography is maintained in case there are plural solutions. The parametric sketching tools in GraphicAlc were specifically developed for function modeling rather than form modeling, because as the number of constraints increase in GraphicAlc, the performance of the sketch will stay flat. So now let's constrain a circle with its center at the endpoint of this line, and let's constrain another circle, something like this. So now I will start giving values to constrain the geometry mathematically. So let's set up a cell here and let's enter 40 millimeters in the GraphicAlc formula bar. The GraphicAlc formula bar is syntactically similar to formula bars found in most popular spreadsheets. So essentially, if you are familiar with using a CAD sketcher and you know how to use a conventional spreadsheet, you're already trained on how to use GraphicAlc. So this is the value I set up here, and let me constrain the radius of this circle. I click on the radius freedom here. This is the value bar which shows the current values of the selected geometry. So I click on the letter R and then I click on the cell here. So the radius of the circle on the right is now driven by the value in this cell. And I will make the length of this line, I'll double click here to activate the length constraint, and the length I'm going to enter 50 millimeters. That will represent the distance between the two centers. And Now I really don't need this line anymore, so I can delete it. Click the right mouse button and just delete the line. Next, I will constrain the intersection. So to do that, I choose the arc tool and click the center of the arc at the center of the circle. You notice how the constraints are being inferred automatically. Likewise, I'll constrain the second arc, and now I'll select the two arcs and I'll say define an area. So now this is the area of the intersection. I have mouse control pan and zoom, so I can zoom in a little bit. I can move this out of the way, maybe here, and I can click on the circle and declare this to be another area. I want to distinguish, so I can select the pattern here, change the pattern, so I can distinguish between the two areas. Now I can put measurements here. So this is unknown. This is being driven by the value of this cell here. So next I will use the automated graphical calculation technology to calculate the values of the geometry. This is a breakthrough technology. This is industry first. There is no mathematics involved in performing geometry dependent calculations. For example, if I want to calculate the area of this lens here, take the calculation tool, place it someplace, and just simply click on the geometry, the tag for the geometry, which is computer generated, and you can come back and rename the tag to anything you want, augmented by the area built-in function, which is a default built-in function, is placed in the formula bar. I click on the OK button. This is the area. So most frequently, the most likely built-in function that you need is automatically inferred and placed in the formula bar. But let's say I wanted to calculate the moment of inertia of this shape. I will click the cell and place the cell somewhere in the sheet, and I can select the built-in function and select the next level of built-in functions. Are most commonly used built-in functions are available in the pull down. And if I wanted a different value, for example, I want ky, so I can manually enter that and it'll give me the ky value. And once these calculations are set up, if the geometry changes, the calculations update automatically because they are geometry synchronous. So coming back to the problem, let me delete this and delete this because we don't need it. Let me calculate the area of the circle on the right, and then I will find the ratio between the area of the circle and area of the intersection. So I can take the calculation tool, click on this cell, divide by, click on this cell here, and that is a current ratio between the area of the circle and area of the intersection. And my target is to make this area equal to half the area of this circle, so I will put my target here, which is 2. So next I will back solve the radius of the circle here, use the goal seek command, and make this ratio equal to this ratio by changing the radius freedom. And that's your answer. And now the goal seek has been set in, so if I change an input condition, the model will be solved automatically to reflect the change. So let's change the radius of the circle on the right. Let's make it 35 millimeters. Immediately you will see that the radius of the left circle will be updated. So essentially this is the principle of operations of graphic calc. You combine geometry, dimensions, empirical values in a single worksheet, and then you can use the wizards for motion simulation, for transient data collection, for tolerance analysis, to perform what-if analysis of your design challenges, to validate your design options. And this way, because you have prepared your essential engineering intent, before you proceed to more expensive product development resources such as modeling or FEA and manufacturing, you will be preventing uh, costly redesigns, and essentially you will be able to develop higher quality products in less time than before. Thank you.